So skeletal formula is a simplified structural formula, and essentially what it is it's a formula where none of the atoms have been included. So each carbon is represented by each point here in the drawing. So obviously that's one carbon, and then here's another carbon, etc. And this is butane right here. Butane. And it would most commonly be found as sort of in this displayed formula here. Just going to draw that in for you guys, the hydrogens. So we can see that the sort of differences between this is skeletal formula and this is displayed. That we can see the differences that obviously in displayed formula you can see all the hydrogens, you can see all the carbons. In skeletal you can just see the points of the different carbons and the sort of bonds here. So if I were to say, can you guys draw the skeletal formula of propane? Just go ahead and draw that for me. Right there, I'll give you a couple seconds. So propane has 3 carbons, and it would be drawn like this, like a little triangle without the base. And here we can see the first carbon, the second carbon, and the third carbon, or the other way around, so the third carbon and the first carbon, So that's propane. And here I keep the butane example up here for you guys, just to refer back to. Now, important thing to remember using skeletal formula is any functional groups are displayed. They're the only atoms displayed, the important functional groups. So say we have butanol. We would obviously use our skeletal for the carbon skeleton right here. And then we'll make this carbon butane 2-ol. Carbon butane 2-ol. So we'll put this in red. See here that you still have to represent the OH there. You can't just say butane 2-ol and just put the carbon skeleton there. So say for example we look at butanoic acid, where we have our sort of COOH bond. Well, let's see how we can draw that with the skeletal. So we have our 4 carbon skeleton here, and on the end here we're going to do our double bond to the O. This is our C, this is our O, this is our OH. You see, it's why it's used is so much quicker and so much simpler than drawing out, the 4, then the O, then the OH, and then all the other hydrogen, you know what I mean. So that's the main reason why it's used. Now if I was to say, can you draw out pentane 2-ol for me? Just go ahead and draw that out on whatever sort of paper you have in front of you. Some whiteboard maybe. Give you like 5 seconds here. Alright, so pentane 2-ol would in fact have a 5 carbon skeleton. So we're looking for this almost M shape here. And at either this carbon atom or this carbon atom, it makes no difference. We'll do it this one. Expect a OH molecule here. And then do the same for pentanoic acid. Just right here. Just draw the skeletal formula for pentanoic acid. At the other side, I will draw the displayed formula. Alright, so you should have drawn that by now. Here we have the displayed formula of pentanoic acid, and the skeletal formula here should be drawn as following. So we should have sort of OH going off here, and you could have had that the other way, so you could have had sort of the double bond coming up here, and then the OH coming down now. Now, what I also want to look at is alicyclic hydrocarbons, alicyclic compounds. So, be good to look at is maybe cyclohexane. Obviously, you guys know that this is the displayed formula, cyclohexane. And this way of drawing the skeletal formula of cyclohexane is so much easier than drawing the displayed formula. So just go ahead and draw the structural formula of cyclohexane. We'll see what we have in a couple of seconds here. So we would have just this sort of hexagon shape right here. There are 6 carbons at each point. This is typically referred to as carbon 1. The skeletal formula is carbon 4. Okay, so if I will now ask you to draw cyclobutane 2-ol for me. Should time here, I will draw it in displayed formula. You guys here? So cyclobutanol should be in a square, which is very nice, as skeletal form, but typically we like to draw them just as a little diamond here. Just as a little diamond here. And you could have picked either this carbon or this carbon to draw the OH off of to make it an alcohol. But there we go. So if I ask you guys to draw a let me think here. Butane 1. I'll draw the displayed formula for you guys here. You guys might not know this. But this is a ketone. What's defined as a ketone? And we're just drawing the displayed formula here. And I'd like you guys to draw the skeletal formula. Now that you know what this displayed formula is, I'd like you guys to draw this displayed formula of butane 1. Start drawing it in here, which you guys are going to. So obviously first we're going to start off with our 4 carbon skeleton right here, and then on either this carbon or this carbon we will have our double bond oxygen coming off there. Oh sorry, that hydrogen should not be there. Right, and last one I'm going to try and get you guys to draw is propanol. Now I'll draw the propanol. I'll draw the displayed formula for you guys here. So here we have 1, 2, yeah, so there's going to be one more H here. Now I'd like you guys to just see if you can draw that in skeletal formula. It's always good to try and draw it with different functional groups just to help get in the flow of drawing out the structural formulas. So here we should have had our 3 carbon skeleton here, and just off of one of these 2 end carbons we should have had double bond to the O. And this is what's classified as an aldehyde. Sorry, I should have put this before, but it's okay. This is a ketone. This one up here was actually a carboxylic acid. So now that you guys know the basics of drawing skeletal formula, I'm going to give you three compounds to draw. So first, octane, just octane. Secondly, I want you guys to draw cyclohexane. And thirdly, we haven't looked at this, but I just want you to do an alkene. So we're just going to go for butene. Butene right here. I'm going to give you guys about 30 seconds to draw those three. And just pause the video here. See if you guys can go ahead and draw them. So first for octane, we know it's a straight chain alkane. So we're literally, all we have to do is draw the 8 carbon skeleton. 1, that's 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, 7, 8, octane. Perfect. Now we're looking at cyclopentane. Cyclopentane, right here. And we're just going to draw this nice little circular pentane right here. Obviously with our 5 carbons, but joining up in a ring structure. And here we have butene. Now I'm going to draw the double bond in red, but you guys don't have to do this. I also didn't specify where double bond is, but because typically ones are not drawn, not put into names, I would have expected you to have sort of included but1ene, not but2ene. So here it should look something like this with a double bond here or here. And that's going to wrap it up for this video. So hopefully you guys now know how to draw the skeletal formula for many different functional groups, straight chain alkenes. Thanks for watching.